Okay, hi, morning everyone. Welcome to my presentation on just a summary of the use of nitric oxide and ozone fumigation as alternative post-harvest phytosanitary treatments. So most of you know that Phyla is a Hordgrow-funded facility. We mainly focus at looking at older new technologies to either kill the target pest and pathogen while maintaining fruit quality. So we have this really integrated approach to most of the projects that we run. So currently, two of the new technologies that we are examining falls under ozone and nitric oxide fumigation using ultra-low conditions. Just to give you a little bit of background on ozone, ozone is used as an antimicrobial agent, but it can also cause, the oxidation of organic molecules, so that can result in cell membrane damage and then eventually rupture. So in the US, they are currently using it to control mold and fungi, and we were in the US now, and the organic people are very interested in the use of ozone because they can't use fluodoxanol and they also can't use 1-NCP. So they are very interested in the potential that ozone has as a phytosanitary treatment. So the other benefit of ozone is that it can potentially also control certain target pests, like they've seen in stored grains and in table grapes. So for our trials, we wanted to examine the effect that it would have on certain pathogens, as well as external pests, and then just have a look at the effectiveness that it would have as a sanitizer to maybe lower the spore load on bins, lugs, and surface areas. Obviously, I can't discuss all of the results, so I'm just going to be looking at the effectiveness on controlling certain external pests and the impact that had on fruit quality. So this is just an example of an outline of the trials that we conducted. So we had various apple and pear cultivars that we tested using the regimes outlined in that table to see what the fruit quality would look like under those conditions. So we had a zero, so no ozone was added, and then we had a lower dose of 500 parts per billion, and then a high dose of 2 parts per million, so for once a week. So the two parts per million, the idea was that you try and get the spore load immediately down, and then you just do maintenance during the duration of the total storage. We were also looking at the effect it would have on grain chinch bug and red spider mites. We have a PhD student that will be looking at that further. And as a pilot, we added some other pathogens to see the effect that it would have on those pathogens. And once again, Leander is taking that work further in his PhD. So I'm going to just highlight certain results which could show you the potential for that parameter that I was saying. So if we look at red spider mites, the eggs are the most tolerant, as we know, and it's also the biggest pet peeve of everyone in the industry. When you talk to them, they want to know how they can get rid of the eggs. So we had various treatments that we used to treat the eggs and look at cell viability, and the ozone-treated eggs had very low hatch rates compared to the controls. So ozone definitely damaged the eggs, and if you would add then cold as a multiple stress on top of that, you would get 100% mortality. So we have put it in for a project at Hordgrow now where we will be looking at how to define that better, so that if you look at the eggs, you would be able to tell if they are going to be viable or not. So once you have your insect data, you can then overlay that with fruit quality data. So for various apple and pear cultivars, we ran central composite design models. So we used various concentrations of ozone and duration of ozone just to see what the damage would be. But for this presentation, I'm just going to highlight from the table that we used, the treatments from there. So we specifically looked at lenticels because that is everyone's biggest worry when it comes to ozone, is the potential in lenticel damage that you can experience, especially when you go high or if you go high for long. But there was no significant difference in damage observed between the treated and untreated control. So it definitely has potential to control something that has eggs potentially. So the other technology we were looking at is nitric oxide. This you have to use under ultra-low conditions. So for this, we used a model called a central composite design, where we used concentrations of 1% to 6% nitric oxide with combinations in durations of between 1 hour to 24 hours fumigation. So with this model, you don't need 100 experiments. You can maybe do 10 experiments, and it'll show you the effect that that would have on that specific commodity or insect. So once again, if I look at spider mites, we could see that the adults were easier to control. We could control them after 4 hours at 1%, but the eggs were the most tolerant. So we needed to go a lot higher for the eggs, or you had to have a lower concentration, but for a longer period of time before you could control them effectively. So where that comes into play is you need to overlay the data that you get from your insects onto the fruit quality so that you can create that perfect treatment without killing the product, but killing the pests. So when we looked at CCDs that we ran for rosemary, for example, and for phorale, we could see that phorale was more sensitive to nitric oxide than rosemary. So you would have to adjust your treatment schedule according to the cultivar to prevent any damage from occurring. So there's definitely a difference in how each commodity tolerates or how susceptible they are to nitric oxide. So you definitely need to do small models for phytotoxicity or any of the other quality parameters, and then overlay the insect data with that so that you can see where the perfect model is for you to run a treatment to have successful control of the insects and pests while maintaining fruit quality. So this is just an image of some of the damage that we observed with a higher dose of nitric oxide on apples. Okay, so I just want to thank all my phyla staff and all the students involved. This takes a lot of hard work. It's not always easy. And for Hood Grove for funding the facility. Anyway, thank you.